Welcome. Today we take few more problems of this question paper CBSE class 12 in 2019. This is sixth part of that question paper. Today we first take the problem question number 222. The question is, if I plus j plus k, comma 2i plus 5j, comma 3i plus 2j minus 3k and I minus 6j minus k respectively are the position vectors of A, B, C, D. Then find the angle between AB and angle between AB and CD. Find whether AB and CD are collinear or not. So we have to find, first of all, we have to find angle between AB and CD. A, B, C, and D are the position vectors. This, and that. From there, first find AB, vector AB. Let it be X is equal to position vector of B minus position vector of A is equal to, position vector of B is this, 2i plus 5j minus I plus j plus k, which is equal to I, they together is I, plus 4j and minus k. This is the vector AB, which is known as X. X vector is equal to that. Similarly, Y vector is equal to CD vector. It is position vector of B minus position vector of C is equal to position vector of D minus position vector of C. Position vector of D is this, I minus 6j minus k minus position vector of C is 3i plus 2j minus 3k, which is equal to minus 2i, then minus 8j, then k plus 3, that is plus 2k. Now, angle between two vectors A and B, we know that if it is theta, then cos theta is equal to x dot y by magnitude x into magnitude y. X dot y is dot product of this and that. It is equal to minus 2 this into that, minus 32 minus 4 divided by magnitude of x, that is of that root over of 1 plus 16 plus 1 into root over of magnitude of y means minus 2 whole square minus 8 whole square plus 2 whole square. It is equal to 36, 30 minus 38 divided by root over of, this is 18 into root over of 72. It is equal to minus 38 by, it is root 9 into 2, root over 8, 18 into, it is 2 into root over 18. It is actually 2 minus 38 minus 2. Oh, sorry. This is 2. Just now you see, this is minus 2 minus 34 into 8 and minus 1 into 2. That is 2. So this is 36. Sorry. This is 36. So it is equal to minus 36 by, they together is 18 into 2, 36 is equal to minus 1. So cos theta is equal to minus 1. So theta, angle between x and y, that is AB and CD, is cos of minus 1, that is 180 degree, that is phi. Angle between this and that is phi. Angle, I mean 180 degree. Achha. Once again, this can be shown very easily in that way. Vector y, you see, it is equal to, taking minus 2 common from there, I plus 4j minus k, taking minus 2 common, minus k. It is equal to minus 2 into x vector. So if one vector is x, other vector is minus 2x. Minus 2x is either this way, minus 2x, or it is somewhere there on a parallel line. So angle between this and that, or angle between this and that, they are 180 degree. So no need, if you do like that, you can express like that, no need of calculating this one. So it is 180 degree. The next part. Find whether AB and CD are collinear or not. Oh, the vectors actually, you see, x and y, AB and CD, it is actually equal to this and that. It is actually x is equal to minus 2, y is equal to minus 2x. In fact, one is x, other is minus 2x, or this. So actually they are collinear. So next problem is 23. Problem number 23 is, find lambda so that 1 minus x by 3 is equal to 7y minus 14 divided by lambda is equal to z minus 3 by 2 and 7 minus 7x by 3 lambda is equal to y minus 5 divided by 1 is equal to 6 minus z by 5 are at right angles. So two straight lines is given, this and that. One unknown constant lambda is there in that equation. You have to find the value of lambda so that these two straight lines are at a right angle. This is first part. Also find whether the lines are intersecting or not. First of all, let us write the equation in standard form. It is always of this type: x minus a by L is equal to y minus b by m, etc. So this is equal to the 1 minus x by 3 is there, so it is x minus 1 by minus 3. Of that type, x minus a by L is equal to y minus 2 dividing by 7, y minus 2 by lambda by 7. I divide throughout by 7 in order to get to a standard form. It is equal to z minus 3 by 2. And second equation, this also 7 minus 7x. So we have to divide by 7 and multiply by minus 1 in order to get to the standard form. So it is equal to x minus 1 by 3 lambda by 7. 7 minus 1, but x minus 1 by with a negative sign is equal to y minus 5 by 1 is equal to z minus 6 by minus 5. Now we get two equations in standard form. They will be at right angle if minus 3 into minus 3 lambda by 7, this into that, plus lambda by 7 into 1 plus 2 into minus 5 is equal to 0. That is 9 lambda by 7 plus lambda by 7 is equal to 10, gives 10 lambda by 7 is equal to 10. So gives lambda is equal to, cancelling by 10, it is 7. So value of lambda in that equations, this and that, lambda must be 7 in order that they are at right angles. Now, for next part, we have to see whether they are intersecting or not. For that purpose, we have I erase this part. For that purpose, we write lambda is equal to 7 in this equation and that equation. This becomes x minus 1 by minus 3 is equal to y minus 2 by lambda is equal to 7 means 1 is equal to z minus 3 by 2. Let it be R1. And second equation become x minus 1 by lambda is 7, so it is minus 3 is equal to y minus 5 by 1 is equal to z minus 6 by minus 5. Let it be R2. So, general point on this straight line, first straight line is 1 minus 1 minus 3 R1 from here, this to that. This is equal to 2 plus R1 y coordinate, and z coordinate is 3 plus 2 R1. This is for any value of R1, this is any point on that one, on that straight line. From second equation, general point is 1 minus 3 R2, 5 plus R2, 6 minus 5 R2. So, for any value of R1, this is a point on the first equation, and for any value of R2, this is any point on second equation. This. Suppose they are intersecting. In that case, for particular value of R1 and R2, these 2 points will be same for particular value of R1 and R2. For that purpose, we must have 1 minus 3 R1 is equal to 1 minus 3 R2. This is equal to that. From second one, 2 R1 or 2 plus R1 is equal to 5 plus R2. 3 plus 2 R1, 6 minus 5 R2. Now, if they intersect, then for particular value of R1 and R2, these 3 equations will be satisfied. Solving first one equation, we get 1 cancels, R1 is equal to R2. Putting this value in second equation, this become 2 plus R1 is equal to 5 plus R2 means R1, giving 2 is equal to 5, which is not possible. So, clearly from this, there are no such R1 and R2. For that purpose, these 2 points will be same. That is, they are not intersecting. So, this is about the second part. The next problem. The next problem is problem number 24. Question is, if A is equal to matrix 3 3 matrix 1 0 1, just 1 minute. One, not 101, 111, then 102, second row, and third row is 311. Find, if A is equal to this, find A inverse, and hence solve the system of equations x plus y plus z is equal to 6, x plus 2z is equal to 7, and 3x plus y plus z is equal to 12. 12. It has also two parts. First of all, we have to find A is a matrix, square matrix. We have to find its inverse. We know that A inverse is equal to 1 by det A, my determinant value of A, into adjoint of A. We know this one. Now, where A is determinant value of A, calculate it first. At determinant value of A is equal to 111, 102, 311. It is equal to, in so many ways we can calculate it. Straight cut way, we expand it along the first row. 1 into delete this row and this column, so 0 to 1 1. Then minus 1, delete this row and this column, so 1 2 3 1, plus 1 into delete this row and this column, that is 1 0 3 1, so that it is equal to 0 minus 2, this is minus of 1 minus 6 plus 1 minus 0, so that it is equal to minus 6 minus 5 minus 7, so that it is 5. Its value is, just 1 minute, 4. Oh, sorry. 1 2 3 1. 1 2 3 1. 1 2 3 1. This one into 1 2 3 1. তাহলে this become 1 minus 6, so that it is minus 5 plus 5, so that minus 2 plus 5, and this is 1, so 5, no, so answer is 4. Value of that determinant is 4. Next, to calculate adjoint A. Adjoint A, before to get adjoint A, first you calculate cofactor matrix of A. This is equal to, it is A is a 3 3 matrix. Cofactor matrix of A, it must be 3 3 matrix. First element will be cofactor of that element, cofactor of that element in that matrix. This is 0 2 1 1, that determinant. It is, I am writing as minor of that element, this is equal to simply 0, 2, 1, 1. Next, this minor of that element, that is 1, 2, 3, 1. And here for that element 1, 0, 3, 1. Now minor of this element 1, it is actually 1, 1, 1, 1. I obtained it by deleting this row and that column 1, 1, 1, 1. Minor of that 1, 1, 3, 1. Minor of this, it is 1, 1, 3, 1. Minor of that 1, 1, 0, 2. Then minor of that, it is 1, 1, 1, 2. And last of all, minor of this 1, 1, 1, 0. This actually we get, this is the all these are minors of that element. Cofactor matrix means we have to find the cofactor of all elements in that, not minor, cofactor. For that purpose, we have to add some sign, whether plus or minus. For that purpose, this is equal to actually minus 1 to the power first row plus first column, that is minus 1 to the power 2, that is positive. It is negative. This is positive, this is negative, positive, negative, positive, negative, and positive. Before each small determinant, we have to add the minus 1 to the power row number plus column number. Suppose for this, it is minor of that. So minus 1 to the power row number is 2, column number is 3. 2 plus 3, 5. So minus 1. That's why I add one negative. Now simplifying, we get this is equal to, it is 0 minus 2. This is 1 minus 6, that is 5. 1, 0, minus 2, 2. This is 2, minus 1, minus 1. This is cofactor matrix of A. Then adjoint A is equal to transpose of cofactor matrix of A, which is simply transpose of that matrix minus 2, 0, 2. First column, write it as first row. 5, minus 2, minus 1. 1, 2, minus 1. This is adjoint matrix. And let us check. Minus 2, 0, 2, 5, minus 2, minus 1, and 1, 2, minus 2. Okay. Then inverse matrix. A inverse is equal to 1 by determinant A into adjoint A. So A inverse is equal to 1 by 4. Determinant value of A is 4. So 1 by 4 into adjoint is equal to this one, minus 2, 0, 2, 5, minus 2, minus 1, 1, 2, minus 1. Yes, this is A inverse matrix. First part of the problem is over. Next, to solve this system of equations, linear equations. To solve it, the A inverse is that. Okay. To solve it, the system of equations can be taken as Just 1 minute. The system of equations, given system of equations, can be written as matrix equation AX is equal to B, where A is the given matrix. A is actually 1, 1, 1, coefficient of x, y, z. In second row, coefficient of x, y, z 1, 2, 1, 0, 2, and third y is absent, that's why 0. 3, 1, 1. X is equal to simply column vector, column matrix x, y, z, and B is equal to another column 1 constant terms, that is 6, 7, 12. That is, this into that is equal to this. So we get therefore we get 1, 1, 1, 1, 0, 2, 3, 1, 1 A into x means x, y, z is equal to B means 6, 7, 12. Let us just 1 minute verify it. The multiplying this with that with x plus y plus z is equal to 6. This is the first equation. Second equation is 1x plus 0 plus 2z. So x plus 2z is equal to 7. Second one. Similarly, the third one. Okay. Hence, we can say that uh, xyz, that is x, y, z is equal to, it is A inverse into 6, 7, 12. That is, I multiply this equation by inverse of that. The inverse of this into this is equal to I. I into xyz is xyz. In left I have multiplied A inverse, so it is A inverse of that. Hence we get, I put value of A inverse from there. It is, I write it here. A inverse means this 1 by 4 on left hand side is xyz. 1 by 4 into matrix 2 0 minus 2 0 2, 5 minus 2 minus 1, 1 2 minus 1 is equal to 1 by 4 into B, sorry, into B. Here is B means 7, 6, 12. So xyz is equal to 1 by 4 into product of these two. First element is this multiplied by that, minus 14 plus minus 14, 0 plus 24, minus 14 plus 24. Two zero two 7 6 12. 7, that is minus 14, 0 12. so that it is equal to 12. Then next one is this multiplied by that, minus 35 minus 12 minus 12. Oh, it is 4. It must be 4. Somewhere I have mistaken. Uh, Up to this is okay. So xyz is equal to a inverse into that is also okay. So this is equal to 1 by 4. A inverse means 202, 5 minus 2 minus 1, 1, 2 minus 1 into uh, B matrix is 7, 6. Oh, I have mistaken there. This is 6, this is 7, and this is 12. So that it is equal to minus 12 plus minus 12 plus 24. Second one, 30 minus 14 minus 12, and last of all is 6. It is 14 minus 12. So it is equal to 1 by 4 into 12. That together is 12. It is 1 by 4 into 4. This is 30 of 30 minus 14 minus 12. So 30 minus 14, it is simply 26. So 4. And last one is 8. It is 8. So that it is equal to 3, 1, 2. So we have started from there. X is equal to 3, y is equal to 1, and z is equal to 2. So our answer is x is equal to 1, y is equal to second element, x is equal to 3, y is equal to 1, and z is equal to 2. This is our answer. Okay, let us stop today. Uh, from problem number 25, we next day we